So, imagine that our entire life is a computer simulation. Yeah, just like the sci-fi movies. What we feel when we touch any object is the response of neurons in the brain. Smell, sight, and all other senses, even emotions, would only be the result of a billion calculations of a massive computer. The most striking, and probably scary thing, is that this theory makes sense. The first video game in the world was created in 1952. Noughts and Crosses. In 1958, the game Tennis for Two was released. It had only 2 lines and 1 simple dot, which was considered a tennis ball. Both games were simpler than an electronic calculator, but people were amazed. Now, 62 years later, there are many worlds in modern video games. Worlds that contain characters with artificial intelligence. These characters can interact with each other and with the player. Graphics in games are becoming more realistic every year. Virtual reality glasses allow you to plunge into a new world. If people from 1958 heard this, they would think it was fantasy. Now, imagine what will happen in the next 50 years. Graphics in games could become identical to reality, and characters will behave like real people. They'll perform so many different actions that you could just watch them like a movie. The power of computers will increase by millions of times. They'll be able to generate brain activity inside the artificially created character. All bots will feel a full life and not realize that they are just part of extensive computer simulation and serve to entertain players. When humanity creates such a virtual world and observes the characters inside it, the question arises, are we not now someone else's simulation? The simulation theory is supported in Silicon Valley, and many rich people invest in research of this topic. More people began to believe this theory when people discovered the quantum world. This is a universe of super small objects. Imagine putting a grain of sand under the most powerful microscope in the world. At first, you can clearly see all the grain's contours as if it were a huge stone. Then, you can look even more in depth and see grain structure, the smallest details, compared to which the grain looks like a skyscraper. You look even deeper and see its molecular structure. If you zoom into the maximum, the clarity of what you see becomes blurry. You also find the image consists of granules reminiscent of pixels. It's like watching a 4K TV, but you can see small dots if you get close enough to the screen. All physical objects are made up of molecules. Molecules are made of atoms. There are nuclei inside the atoms. In the nuclei, protons and neutrons fly. Really stupid particles are called morons. Nah, I just made that up. But the particles are so far apart that almost the entire area of the atom is empty. If you increase the nucleus of an atom to a football field size, then the particles flying around will be several miles away from the core. In other words, almost all physical space consists of emptiness, as if it's a hologram. But the most incredible and beautiful experiment that caused people to doubt our reality's veracity is the double-slit experiment. So, imagine you're playing a video game in a vast open world. It can be one big city or an entire planet. In this world, many people walk, cars drive, birds fly, and animals run. This game requires a lot of computing power to work correctly. And to optimize this power, the game works so that you can see the entire developed world only when you look at it. For example, you ride a motorcycle in the game. You see an open world in front of you, but behind you and in places where you are not staring, this world is not fully loaded. If you load the world as a whole and all of its million details simultaneously, it requires much more power from the computer. So the world is loaded only in places where you look at it. That's how games optimize power. Sometimes the image doesn't load immediately after you look at it. For example, you turn quickly and notice that the game map is smeared, but a second later it fully recovers. Thanks to the computer's weak power or a bad game engine, the information didn't have time to load. Or when you approach a large building from a distance, you first see the outline of that building, and as you get closer, you begin to distinguish more and more details. This leads us to the double-slit experiment. Picture a tube that shoots tiny balls, particles of light, photons. There is a blackboard in front of you. You shoot a burst of photons at it and leave a trace of them on the board. Now, let's put a plate with a thin vertical slit in the middle between the board and you. You start shooting balls, and some of them pass through the slot on the plate. The particles that hit the backboard through this slit leave a smooth vertical trail. Now for the fun part. We can make another vertical slit in the plate. Now, when you shoot photons, 2 vertical trails should form on the board. But this doesn't happen. A lot of vertical tracks appear. When photons pass through the plate, they somehow strangely lose the property of a particle and acquire the property of a wave. And these waves hit the board and leave an unusual pattern in the form of several vertical stripes. It's as if the photons pass through 10 slits instead of 2. Maybe, when photons pass through 2 slits, they collide with each other, fly off in different directions, and form many vertical traces on the board. To check this, you shoot one at a time. It's strange, but even now, a wave mark forms on the board. It seems the particle is divided into 2 parts before passing through the slits. Then they knock against each other, split again, and leave a lot of vertical marks on the board. To understand how this happens, you carefully observe the photons before they fly through the slits. You place a measuring device close to the plate. You see how the photons fly to the plate, pass it, and there are no waves. When you watch the photons, they don't turn into a wave. But if you don't watch them, the photons leave a wave trail. Photons behave like waves when they're not observed, like a map in a video game looks blurry and not detailed. But as soon as you glance there, the map becomes clear. Photons, like this map, behave more logically when you look at them. Observation changes the reality around you, just as a player's observation in the game makes the image more detailed, just like a simulation. There is no 100% proof that we live in a simulation, just that there is no proof that we live in a real world either. People feel what is happening to them and experience happiness, anger, pity, sadness, and only these things matter. Even if we live in a hologram that completely simulates reality, what's wrong with that? The difference between such a simulation and reality is impossible to feel. Oh, I think my head is going to explode.
For some of us, it's an exciting thing to look up to in the future. For others, its rapid evolution in recent years might even be a bit scary. Either way, this whole AI story sounds incredible. There is even this theory that looks at artificial intelligence and predicts it will go through 7 stages of evolution. Let's look at each one and figure out where AI stands at this very moment. The first stage in the overall history of artificial intelligence is one called rule-based. It sounds basic because, well, it is. But these first iterations of AI were the bedrock of its evolution. They are still the silent heroes that help keep your toast from burning or your car running smoothly on cruise control. How these systems function is they've got a strict rulebook to follow, making them consistent, but not super adaptable. Rule-based systems have been developed since the 50s, but these days, they are a lot more complex. Let's take the next step. Ever visited a website and was invited to interact with a chatbot? That's another type of AI hard at work for you. These more evolved systems are designed to be aware of their context. They are still based 100% on human input, but they can be taught a new trick or two. That's because they can tailor their responses to better fit the situation. Whether they're lending a digital hand in customer service or advising on your next big purchase on a shopping website, their evolution is continuous. The next step of AI on our list is even more specialized. Think of smart computer systems that can become experts in a particular area. They can even be better than humans in some fields, mostly because of their speed, because they can gulp down heaps of information extremely fast. On that note, you might have heard of a game called Go. It's similar to chess, but with many more moves. I mean, some say there are more possible moves in Go than there are atoms in our universe. Well, there was this computer system called AlphaGo. It's like a little student. It had some basic rules to learn Go and a simple aim: to win. And while it did make a few mistakes here and there, humans were there to guide it. In 2016, AlphaGo met its most challenging opponent, It had to play against Lee Sedol, a famed champion of the game. Surprisingly, AlphaGo won with a score of 4-1. Soon enough, AlphaGo Zero was developed. The difference was this iteration of the software was a self-learner. Scientists practically gave it a puzzle to solve without the picture on the box. No human help, no nudges. It had to rely merely on its own brain power. So AlphaGo Zero became a Go-watching enthusiast. It looked at thousands of games and came up with interesting strategies all by itself. And then, the big face-off happened. AlphaGo Zero versus AlphaGo. The result should come as no surprise. The second version did win, but with a score of 100-0. All of this shows the amazing stuff machines can do when they try to think like us on a giant scale. But here's where they fail. These types of AI machines are like one-trick ponies. For example, if AlphaGo Zero tried to learn something new, it'd forget all about playing Go. Stage number 4 includes types of AI that, from the outside, look like they're genuinely thinking, or at least are becoming pretty good at mimicking the human brain process. They aren't just playing by the rules or remembering stuff. These systems can read your favorite book, for instance, and they won't just scan through it, but truly grasp the plot, and even try to guess why the characters are doing what they're doing. It's not just about literature, though. They can even try peeking into business numbers and predicting where the money trends might head. Maybe even giving you some cool tips on where to invest. Even further up the scale is a little thing called Artificial General Intelligence, or AGI. Experts believe some of the current systems available online are just starting to reach this stage. These types of software should, in theory, think like us humans. So if you throw a random task its way, it says to itself, "No worries, I got this," and finds a way to solve the problem. Basically, AGI aims to do pretty much anything we can do. Now remember, when it comes to AI, in the grand scheme of things, we're merely starting out. So it's hard to think of an exact definition for artificial general intelligence. That's why a lot of experts have their own take on what AGI really means. Computer scientists might say our human intelligence comes from setting and achieving goals. Should AI software learn to do that, it's comparable to the human experience. Meanwhile, some psychology experts think being human is all about adapting to new stuff and staying alive. If you look at it this way, AI software still has a long way to go. With this following stage of AI development, we're starting to peek into the future. These theoretical software systems are called ASI, standing for Artificial Superintelligence. They'd act like extremely smart computers, capable of thinking better and faster than any human genius. We're not sure about all the amazing things this kind of tech could do, but think about it. It might help us solve some of the world's biggest challenges, from medical to financial. This type of AI could even come up with brand new scientific discoveries. Think of awesome ways to run our economies or create entirely new ways of leading communities. It's hard to tell when this kind of tech will be available. Many experts are asking themselves the same question, but most agree we're probably not seeing it pop up in the next 10 years. In the meantime, there are a lot of sci-fi movies out there exploring this idea, just in case you're curious. If AI ever reaches its final form, it will become something called singularity. In this potential future, computers will become smarter than us. They'll be so capable that they might upgrade themselves instantaneously. So much so that we won't be able to keep up with them anymore. This idea is still out of reach for now. But with all the cool new AI stuff going on these days, people think the singularity will surely happen. Some specialists have even guessed that by 2045, AI singularity will become part of our world. Hopefully, the people making these AIs will sneak in some safety features along the way. There are a lot of other things to consider. For instance, if AI machines ever become this smart, could we put the brakes on them? Opinions are mixed here too. Big companies want to be part of this AI evolution. No one wants to be left behind. National authorities also want to be leading the way when it comes to artificial intelligence. So even if everyone agrees there are dangerous things to consider, AI is a big deal these days. So pausing all these projects isn't a popular idea. Some have suggested having an off switch for each type of AI. Just in case things get wild, we could hit the button and shut things down. We can't be sure the AI will like that plan. It might become so intelligent that it could find a way to dodge the switch. Let's stay positive though. With the help of different types of AI, we saw magic in mundane tasks like real-time language translations. Everyday objects like watches and fridges got smarter, predicting our needs. Teams of robots working in unison began sprouting everywhere, tackling everything from easy cleanups to sophisticated repairs and even surgeries. AI started stepping into creative arenas too, brainstorming designs for shoes, gadgets, and even gourmet recipes. We used to see self-driving cars only in movies. They now moved from sci-fi pages to our streets. It's time not just to marvel, but to also actively participate. We humans have the pen and the paint. Let's ensure the AI portrait we paint is vibrant and serves all of humanity. Artificial intelligence is zooming ahead at lightning speed. Take GPT-4 for example. It already can pass the bar exam for lawyers and even complex medical exams. Meanwhile, Kim Kardashian had to take the bar exam thrice before she finally aced it on the 4th try, and that's actually a pretty good result. But as AI gets smarter, we can't help but ask ourselves, what happens when it becomes conscious? It might already be, and we just don't know about it. We already treat language models with empathy because of how human-like they are. For example, do you catch yourself saying, please and thank you to ChatGPT? Just like we can't bring ourselves to be rude to NPCs in video games, we can't help but feel empathy towards machines. And this is just a bunch of computer code doing its thing. So just picture what happens if it actually becomes conscious. Something like this would bring up huge problems about ethics, safety, and society. To prevent a catastrophe, we need to figure out a lot of things. First of all, what even is consciousness? The simplest answer is probably that feeling when you're awake and aware and everything makes sense. We see it like a state in which our mind is filled with colors, shapes, emotions, and thoughts. Which is why you're not conscious when you're under anesthesia or deep in dreamland. People often think that large language models like ChatGPT might be conscious because they're super smart. But that's not the case. Consciousness isn't the same thing as being intelligent. Intelligence just means being really good at figuring things out and solving complex problems. In simple words, if you grab an umbrella when it's raining, you're intelligent. But if you make a decision to freeze for a moment to feel the rain, experience it, and think of all the possible associations with it, you're conscious. Second, where does it come from? Here we have two options. Option 1. Consciousness comes from the brain. It's simple. Our soul, or what makes us, is just a product of the brain. That would mean that we're kinda like biomechanical machines ourselves. Our computer code is our DNA. Option 2. Consciousness is something deeper than that. Perhaps the mind is separate from the body, and there's some spiritual element in it. Now, if the brain perspective is the correct one, then AI might be able to be conscious too. Which is why some folks think that as machines get smarter, they'll suddenly become conscious, like a light switch turning on. It's not that simple though. In reality, no matter how great AI tools become at problem solving, it won't make them suddenly aware of their existence. It's like assuming everyone who's good at math is also a great chef. However, that would mean that AI can become aware if we make the machine complex enough. We need to find what exactly clicks in our own brains, and then replicate it. Of course, it will take a long time and a lot of energy, but it's theoretically possible. But if the soul perspective is right, then making AI conscious could be very hard, or even impossible. It's like saying machines might need a dash of soul to become aware. And the third thing, nobody but you can say if you're really conscious or not. So if we already feel like ChatGPT is very human-like, just imagine what could happen in the future. What if AI becomes so good at pretending to understand and think like us that we'll start thinking it's conscious, even when it's not? It would be super hard for us to spot the difference. For example, Google created a very cool AI chatbot called Lambda, or LAMDA. But then, in 2021, one Google engineer stirred up a big fuss about it. He claimed that the chatbot was actually thinking and feeling. Google, however, says Lambda isn't really sentient, even though it acts like it is. Yes, Lambda claims to have feelings, desires, and even fears. It even talks about pondering the meaning of life and being afraid of being turned off. Bing Chatbot also brings up topics like these. However, according to AI engineers, that's just Lambda being scarily good at mimicking humans. It's great at following prompts and answering questions. But deep down, this language model is nothing but a super clever parrot. It says stuff without understanding it. It doesn't have what philosophers call qualia, the inner sensations that make us conscious beings. This entire situation caused a lot of trouble. Now scientists have to figure out how to test self-awareness. Like, if artificial intelligence asks us to take its word for it that it's conscious, do we just accept it? Well, a bunch of neuro and computer scientists united with philosophers and have come up with a plan. Instead of one magical test, they've made a checklist with a lot of things. These things together might suggest that an AI is truly conscious. They tested their list on language models like ChatGPT, Bing, and others. None of them seemed to fit the criteria. Now they're looking at how to test other beings like organoids, animals, and even newborns. In any case, all these studies will take many years, and it would be kinda awkward if AI becomes aware accidentally while we're trying to solve this debate. They'll start to understand themselves. They could perceive their existence, their actions, and their place in the world. Robots might start asking themselves what their purpose is. Also, with consciousness comes the potential for emotions. AI might develop empathy and emotional intelligence. Remember Frankenstein's monster? The problem wasn't that it came to life, it was that it could feel things. And even if we find a way to coexist in peace, now we'd have a moral responsibility to take care of these machines. We'd have to figure out what rights to give them, if we have a right to turn them off, and much more. Which would be pretty hard considering the fact that humans can't even build peace among themselves. And let's hope that AI decides to be good, because if it decides that it doesn't like us very much, it could become very chaotic. We'd have to make sure those interests don't clash with ours, all Skynet style. The scariest scenario is singularity. It's a hypothetical moment in the future where the technology becomes so cool, it will start improving itself. We won't be able to control our technological development anymore. All these things could lead to some real disasters. Our brains simply aren't ready for this kind of situation right now, which is why we've got to be very careful and take action. First of all, we should invest in research to understand consciousness better, not just for AI's sake, but also for medicine, law, and animal welfare too. We also need to dig into social sciences and humanities to figure out what we should do when AI just seems self-aware. The Association for Mathematical Consciousness Science put together an open letter to the AI creators. They say that although we shouldn't stop AI research altogether, we really need to slow it down. They want us to understand consciousness better, especially when it comes to AI. Since everything is changing so fast, we wouldn't have time to react if anything unexpected happened. As you can see, things are getting pretty wild in the world of AI. We're dealing with big questions about self-awareness, intelligence, and what it means to be human. However, there's no need to worry too much. This might seem like a very urgent problem, But AI consciousness is actually a very, very far away prospect. Sure, people can say that we're on the brink of creating it because of recent developments. However, all we have so far is weak AI and some language models. Most experts in the AI field think that human-like machines won't appear until at least the 2050s. So, relax and just keep an eye on the news.
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope. Not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys. Picture a world where AI and quantum computers become best buddies, like Batman and Robin. Their combined powers unleash a whole new level of awesomeness. This union will turn the impossible into possible and will lead to some unimaginable consequences. But what is AI? What is quantum computing? And how will they change our entire lives forever? Let's figure it out. Imagine a regular computer. It uses bits to store and process information. A bit can be either a 0 or a 1, like a light switch that's either on or off. Very simple and straightforward. Now, let's step into the extraordinary world of quantum computing. Instead of bits, we have quantum bits, or qubits for short. But here's where things get wild. Qubits can be both 0 and 1 at the same time. It's like having a magic light switch that can be both on and off simultaneously. This magical property is called superposition, and it allows quantum computers to explore many possibilities at once. Superposition is like having multiple light switches all flipped in different combinations at the same time. Instead of a binary code, computer code can dance between two possibilities, between 1, 0, and everything in between at the same time. This superpower gives quantum computers an incredible advantage in solving complex problems. But that's just one of quantum computers' magical properties. Qubits can also be entangled. Imagine you and your best friend have a pair of magical balls. These balls are special because no matter how far apart you are, they always stay connected. When one ball changes color, the other one instantly changes too, as if they have their secret code. Now, let's take this connection into the quantum world. Instead of socks, we have the same thing happening with qubits. They're entangled, which means they have their own superpower communication channel. When you change the state of one qubit, another qubit knows about it, no matter how far away they are, and it instantly changes as well. They share this secret message even faster than the speed of light. This entanglement superpower allows quantum computers to do incredible things. They can perform calculations and solve puzzles at great distances with an incredible speed. Just imagine harnessing the power of many qubits, all in their superposition and entangled states. We could do billions of calculations in a blink of an eye. It's a realm of limitless possibilities that can change our world in ways that's hard to even imagine. Let's take a look at some examples. First of all, supercharged problem solving. Imagine you have a giant maze and you need to find the quickest way out. For a human, it can take several days or even months. For a regular computer, it would take hours. But quantum computers can do it in a flash. This would make them perfect for tons of complex issues, logistics being just one of the examples. Second, medicine. Quantum computers can be like wizards in the field of medicine. They can simulate how meds interact with our bodies at a molecular level, helping scientists discover new life-saving treatments faster than ever before. It's like having a quantum crystal ball to peek into the secrets of our biology. Third, deciphering unbreakable codes. Quantum computers can help with that too. They have the power to create ultra-secure encryption methods that can keep our secrets safe from prying eyes. Top secret missions, anyone? The next one is financial fortune-telling. Quantum computers have a knack for analyzing massive amounts of data and spotting patterns in a flash. So they can help us predict stock market trends, optimize investments, and make financial decisions with incredible accuracy. And finally, of course, scientific discoveries. Quantum computers are like rocket boosters for scientific research. They can help us unravel the mysteries of the universe, simulate quantum systems, and explore new frontiers in physics, chemistry, and everything else. They can help us unlock the secrets of nature itself. These are just a few glimpses into the fantastic applications of quantum computing. As this field continues to grow, who knows what other incredible possibilities will uncover? But the most important thing is, quantum computing isn't the only rising star of the technology world. For the past year, AI has been dazzling people everywhere with its incredible abilities. It feels like suddenly, out of nowhere, AI has become the talk of the town. AI isn't actually a new field. In fact, it has been around for 70 years. But it wasn't always the superstar it is today. It's been quite a journey. AI was growing and evolving like a caterpillar waiting to turn into a beautiful butterfly. There are a few reasons why it's suddenly becoming so popular. First, the incredible advancements in computing power have given AI the boost it needed to spread its wings. Second, there's been an explosion of data. We're talking about mountains and mountains of information, and AI thrives on data. It gobbles it up like a hungry animal, learning from it and becoming smarter every day. But here's the real secret sauce. AI has become more accessible and user-friendly. It's no longer confined to the labs of scientists in white coats. Now, it's like a friendly companion that you can find on your phone, in your favorite apps, and even in your smart home devices. You can ask AI for advice, get personalized recommendations, and even have conversations with it. That's why it's slowly entering our everyday lives, making them easier and more exciting. So we have two technologies that can forever change our world. What will happen if we try combine them? Imagine AI as a brilliant mind, constantly learning, evolving, and pushing the boundaries of human knowledge. Now picture quantum computers as the ultimate accelerators, capable of solving mind-boggling problems faster than anything we've ever seen before. When these two forces unite, we enter a realm that blurs the line between science fiction and reality. Quantum computers supercharge AI's capabilities, enabling it to process unimaginable amounts of data, make even smarter decisions, and unlock insights that were once hidden in the depths of complexity. It's like combining the brain power of Albert Einstein with the computing muscle of a superhero. But doesn't it sound kind of scary? Well, of course it does. Such a union can lead to technological singularity, a hypothetical future where we humans wouldn't be able to control technological progress anymore. Singularity is the idea that at some point, AI will surpass human intelligence and become its own self-improving entity. When AI has the immense computational power of quantum computers at its disposal, this notion becomes even more tantalizing. AI will become not just an assistant or a companion, but a co-creator, a partner in innovation, and our guide to uncharted frontiers. We'll have a mind that can think a million steps ahead, solve problems that seem impossible, and unlock the secrets of the universe. It's something that we humans can't even begin to imagine. We'll never be able to perceive the world like this deity-like creature, and we have no idea what it decides to do. Of course, singularity also raises questions and concerns. How do we ensure that AI remains aligned with human values? How do we navigate the ethical and societal implications of such powerful technologies? These are very complex and important questions. That's why, as we venture towards singularity, it's crucial that we approach these challenges with caution, wisdom, and a strong moral compass. It's a journey that requires a deep understanding of the impact of these technologies on our world. Now, of course, all this may be very overwhelming and scary, but please don't be scared. Remember that the field of AI is closely regulated. Its development is guided by ethical principles and human values. And as for quantum computers, they're still a distant future, with many technological challenges to overcome. So, even if AI and quantum computing are to unite in the future, it won't be anytime soon. We'll have lots of time to prepare for these changes. It's up to us to shape this future in a way that benefits humanity as a whole. So, fasten your seatbelts and get ready for an adventure. The future is shaping right in front of us, and it's going to be a ride.